Okay, so this is data mining lecture one, part two, and we're continuing on with the slides for week one. Okay. So this is what the first part covered that I'm scrolling through very quickly now. And then I left off on something very important. This right here is essentially the structure of the class. The data mining process, there's actually a standards organization called CRISP that has a similar algorithm for what the process of data mining is. And I kind of modified that, but I made it like for our course. So the general pattern of the process of data mining is pretty much the same. Different, like CRISP does like their own like proprietary sort of special specific way of doing it, but it's very, very similar. So I made this myself because I learned how to use the little slide diagram thing. And so what you see here, it's actually like a staircase. So step one, step two, step three, step four, and step five. At the beginning of this course, which would be now, we talk about how to obtain and explore data, and then we do what's called pre-processing. And so this is the beginning stuff. And then most of the course actually focuses on the data mining techniques themselves. And post-processing we sort of do along with data mining. That's like looking at how effective the models we created are and things like that. And then step five, we don't really directly do. You'll do this as part of your project, which is like, what are you going to do with the knowledge that you obtained from data mining? So first you have to obtain and look at the data, then you actually pre-process it. And this involves like modifying the data a little if you need to and possibly transforming it or whatnot and cleaning it a little bit. But most of the course is going to focus on the actual mining techniques. Obtaining, exploring data, that sort of, the realm of intro stats will do a lot of sort of basic stuff there, as will data viz does a lot of looking at data. Pre-processing is, there's a whole data wrangling course coming up in the spring as well. So the data mining techniques is the focus of this course, and that's like the clustering and association and classification. So most of this course is step three, and a little bit of step four, which is looking at how effective the models are in assessing things, and then step five, which is how are you going to use this. Okay. So obtaining and exploring data. Typically these days, this goes back to the history. In the old days, your data would basically be on your computer in front of you. These days, it's in some big data warehouse in the cloud somewhere, and a bunch of IT people are maintaining it. I would find it to be rare that the data analyst is the same person that is actually doing the database behind the scenes work, which is part of the reason why I don't cover like back end data storage platform stuff in this program, because I see that as an entirely different profession. Not data analytics per se. The analytics part is once you actually obtain the data and you're looking at it, not how it's stored and how you like actually comes from. Typically, the analyst will be given data, or one of the reasons you need to know SQL is you may find yourself like on your computer that you're analyzing data, but you have to hook into the database and fish the data out. You would need your SQL to do that, and that's your structured query language, or some kind of related way to retrieve data. That's if, now you wouldn't actually be going to the data warehouse, but you can hook into something and fish data out. That typically, like, you might be given privileges to do that, or somebody might help you or something like that. So, but anyways, somehow at this point you obtain the data. Data is typically uploaded into the software that you're using. So if you're using R, you typically load the data into R, or whatever. You typically, by the way, if you're working with something like SQL, you might have like 20 tables that you're pulling data from. You have to be able to just pull out the data that you need, which may only be like 10 fields total out of all of those tables. Like you might just be looking at like the products they sold and the dates they sold, and you might be pulling something out of some back-end database. And so you're just pulling certain fields and certain things, and you're creating your own sort of analytical files. Because you want to, when you're analyzing data, you have to have a manageable file. You can't be analyzing like everything in the database. It might be big, but I mean, it has to just have like a finite number of variables in it, because otherwise, you can only like mentally deal with so much. But the data somehow gets into the software, which may be R or Python, or in the case of this course, Orange. You may use the same software, or you may use different software. So if you have like some cleaning to do, you're probably not going to do that in Orange. You may do that in Excel or something else. And then you would use Orange to do your models, which is what we're going to do most of in this class, the actual mining techniques. Okay. So the first thing that you should do is you should explore your data. And that just means looking at it. It doesn't necessarily mean doing any fancy stats. Typically, it will be doing frequency tables and maybe some basic visualizations like histograms and stuff. You should also, hopefully, the data is documented and you can know what the variables are. Sometimes it's really easy. I mean, product sold, that's product sold. Date of service, Other times you'll get these weird variables that like you don't know what they are and you have to figure out like what exactly the data is that you're looking at. So I made a little example for you. Suppose a bank wants to build a model predicting whether somebody is approved for a mortgage based on several factors. Employment history, down payment, so this is buying a house, and whether or not you're going to get a mortgage to buy a house. And so you give them your information, like I have a job, I don't have a job, whatever. Usually if you don't have a job, they're not going to give you a mortgage. But unless you have some weird inheritance or something. But anyway, so you have data on various factors, and the goal here is to determine whether or not you get approved. So the analyst obtains data from the IT department with relevant variables, and I just made up some little data sets here. Okay, so here's some data, and it's like credit score and income and employment history. Debt to income ratio is like if you owe like $4,000 and make $10,000. These look like really big ratios to me, but I don't know. I guess that would actually improve. I think this would actually include your mortgage. If that includes mortgage, it's probably not as weird. Loan to value, that's like the percentage of the house that you would mortgage. The property type, house, condo, whatever. How much you put down, the purpose of it, and then whether or not your loan was approved. So this is just like made up data, and this one is kind of pretty understandable. Like even if you had no training in like mortgages and stuff. Credit score is your credit worthiness, income, how much you made, how long you've been working. Debt to income ratio, this has got to be with a mortgage because nobody would have that without. Loan to value ratio, that's the percentage of the house that's mortgaged, the type, the down payment, purpose, and whether or not you approve. So you have your data, and you wouldn't have a data set this small, but you sit there and you just look at it and you figure out everything is. You do that before you start doing anything else, okay? Pre-processing, what is pre-processing? Pre-processing is preparing data for data mining. Again, the cleaning, this part here, the data wrangling course that I'm creating is all about these things. Yes, there's an entire course in this because you wouldn't believe how much there is to actually do and know. Cleaning data, reforming data, transforming data, basically manipulating, working with data, not just SQL, but also a bunch of other things. Reducing the dimensionality of data, that we'll discuss more. We're going to actually cover that a little bit in here. Filtering and subsetting data, like if you have a big data set and you only need part of it. Like you probably don't need what kind of pet people have for whether or not they should get a mortgage, but maybe that's in the database, or maybe you do, I don't know. But I don't think they discriminate based on what kind of cat you have, but they might, never know. Normalizing data we'll talk about as well, and that means converting it to a standard normal scale. And the reason you would want to do that is because that way the units get stripped out, because units can actually interfere with things, like the credit score here. Credit scores are on different scales. There's like different credit scores. There's like FICO and some others. So you might want to convert these to normal scores instead. Okay. And so the credit scores here I'm going to normalize. And that means converting. This is from interest stats, which is the normal distribution. Don't worry if you don't know this because we're actually going to cover this later on. So it's converting it to the standard normal z-scores. And so that's what this does here. You divide by the mean, you subtract the mean and divide by the standard deviation, and then you get a rescaled credit score. Okay, and so some of the data is cleaned as well. Like right here, you see this says APPR. You want to make sure that these are like consistent because this is actually going to be your outcome variable. So that would be a data cleaning issue, and then that's cleaned. Okay. The next thing you would actually do, so now you got your data, you looked at your data, and it's all set to go. I mean, this is just a really small data set, but this is all nice and clean and ready to analyze. So now you actually want to apply your data mining techniques. In this case, the goal is to develop some type of model to predict whether the loan is approved or not approved. So this is actually, if you took 101, we did this in 101, which is we did linear discriminant analysis. That would be an appropriate technique to use here because you want to distinguish. What you want to do is take this data and you want to use this data here, not the last column. The last column is your labeled outcome. But what you want to do is create a model where you feed these in and you predict whether or not a loan would be approved or denied. Okay. So that is a case that we could use something called LDA, which it doesn't matter if you don't know what that is right now because it's just an illustration. But what of these? So the first thing you do is you figure out, like, you have all these variables, or do you need all of them? And the answer is probably not. There's probably some of these that are more important than others. Like the credit score typically is considered something really important, whether or not you get a loan. And if you just look at the data, without even doing like a formal model, you can see that like the low credit scores are the ones that are denied, the ones in red. So, I skipped a step, sorry. It's likely that the normal credit scores and loan to value ratio would be important. The loan to value ratio also because you don't want somebody to mortgage like 100% of their house. That, you guys are kind of young, but when everything crashed in 2008, that was actually why. Because they were just giving people mortgages for like 100% of the property, and that was not a good idea. That's why they make you put like 20% down when you buy a house. So if you look at the data, there's kind of a pattern here, and that's what data mining is all about, finding patterns. And so low credit scores and high loan to value ratios tend not to be good predictors for mortgage approval. And that, in a nutshell, is really the essence of what data mining is. Take the data and look for patterns. Okay, look for useful patterns. And then if you worked in a bank or something, you'd have something to present as a model for predicting things. Okay. And then post-processing would be to be like, hey, now we have this model. How good is it? Okay. So is it sensible and effective? And my answer would be yes. It's probably going to be a pretty sensible and effective model to use the credit score and this to predict whether or not they get a mortgage. Okay. So the bank may test the model with new data or rerun it and see if it's the same model. So you could do, if you took 101 again, what we did is we took a bigger data set and we split it into a testing and training. So you'd actually create the model with the test, with the training set rather, and then you test it with the test set. That's something we're going to look at quite a bit in this class. That's where the sort of post-processing looking at model effectiveness comes in. Okay. So again, you want to, generally your post-processing involves testing out how good your model is. Okay. And then how to actually use it. In this case, I think it's fairly obvious. You would want to use this to approve or deny mortgages. But in other cases, you might have like a nice data mining result. You might have a nice pattern you discovered. But then the question would be, how are you gonna make use of this discovery? So that is, in a nutshell, sort of like just a basic overview of what data mining is. If the model makes sense, the bank can use it to approve or deny loans. Okay, cool. So that is what we're going to learn in here. Is we're going to learn various techniques for taking a data set and looking at patterns in the data, which are actually pretty cool. And so the next learning objective is to look at the tools in data mining. And tools, of course, mean software applications and programs. Technology tools, my take, and I'm an old lady now, and even from the history earlier, a lot of the sort of basics of data mining have actually been around for a long time. The tools will change. The software tools and applications will change, which is one reason why I'm not teaching this program particularly married to one particular tool, because you have to think more that the theory is going to be perpetual. I mean, if you live another 80 years, the theory of data mining is probably going to be the same. You're probably going to go through 20 different rounds of different tools. Okay, so currently, these are my categories, so I kind of made up the different categories of tools. The first thing I say is that there's non-specific software. This would be your Microsoft Excel or Google Sheets. I mean, these are not, quote, data mining tools. These are just general office software kinds of things. They have very limited capacity to do true data mining. Excel might claim that it has, like, Excel actually has some kind of plugins, like Excel Miner. I don't think that actually exists anymore as such, but they actually have plugins that are like, quote, data mining tools. I would call them very limited capacity. I wouldn't consider Microsoft Excel a data mining tool, but I would consider Microsoft Excel a good general use software that you can put data in and look at data and do some basic stuff with, including cleaning, which is what I think we're going to use a bit of it for data wrangling. Google Sheets is sort of Microsoft Excel's free and wimpy pal. I'm not a big fan of Google Sheets because I have Excel and we have that at NCC, so but Google Sheets is the other sort of major software thing. Then there's statistical software. Statistical software has been around a lot longer than data mining stuff. They have built some data mining functionality into it, including the SPSS here, which is the IBM, and the data mining stuff. These guys are typically proprietary, with the exception of R, which is open source. R is a program. We're going to cover R soon, though. These are the more proprietary ones. SAS is very, very expensive. I was using that for applied data analytics because they had an academic deal that they no longer have. Minitab is kind of outdated, and SPSS is sort of pretty much used in academic, like psychology and social science settings, and not so much in industry. The licenses for this are quite expensive. The SPSS is available to students for cheap, but the commercial version is thousands, and as SAS is, I believe, like 10,000 to actually buy. It's very expensive, and there's typically a pretty high learning curve to be able to use, particularly SAS. SPSS to some extent too. I mean, I make it easy in Stats too, but to fully use SPSS, there is quite a bit of a lot going on behind the scenes. These are usually not considered data mining software. These are statistics software. Statistics and data mining are not the same thing. Statistics is a mathematically based subject. It uses probability distributions. The data that statistics deals with, for the most part, is numeric data with a little bit of categorical factor stuff, unlike data mining, which deals a lot with data that is not necessarily numerical. The techniques in data mining do not necessarily rely on probability distributions in math the way statistics does. Statistics does, in fact, I mean, they both work with data, but statistics is a I don't know whether you, I think really statistics can be thought of as a subfield of data analytics and data mining, but do keep in mind the separation of the two. Okay. Then there's data visualization and BI tools. These are actually, and by BI, I mean business intelligence is basically being able to take data and look at it very quickly and effectively. Data mining goes a little bit beyond that. In that data mining, we're looking for specific patterns and we're using specific techniques. Tableau and Power BI, now there's a whole bunch of other ones as well. These are kind of data mining tools. Tableau really is more of a visualization tool. Power BI I kind of sort of like, and we do have that at NCC, but Power BI is not usable by Macintosh users, which is one reason I'm trying not to use it in the program, because it's not accessible to a lot of people. I also don't really know Power BI that much, and I know other things. Tableau is very, very good for visualizations and basic visual intelligence. It doesn't really do data mining algorithms like we're going to look at in this class as well. So this is, I would consider these like your visualization BI tools, your stat software, and your general use software. Okay. The two programming languages, and I would probably put like RStudio. I mean, RStudio is almost a little bit of everything, but the two programming languages using analytics are R and Python. These two languages is pretty much one. I mean, to be honest, I think you're probably wasting your time learning other languages for data analytics, other than SQL. But the two programming languages are R and Python. To me, they're somewhat redundant. There's very little. I don't know Python anywhere near as well as I know R, but there's very little that I've ever seen in Python that can't be done in R. In fact, I haven't seen a single thing that you need Python that you can't use R for. So I think and most of the job ads, when I look at them, it's like either or. You don't necessarily have to know both. The programming languages, of course, allow you to do a lot of customized and more advanced stuff. If you don't know programming, you really can't do much with R and Python. You know, how much programming do you need to know? I don't know. It depends on what you do. If you go and do like a more master's, doctoral level data scientist job, you're going to need more programming. If you're doing a more basic, applied analytics job, like if you're working in a hospital doing healthcare data analytics, you're probably never going to program a single thing. So, it depends on where you're going. What we're going to use in this class is something called Orange. And you're like, why? I discovered Orange. It's actually been around for a long time. It's very, very good software. It's free. It's open source. Orange actually runs on Python. However, we don't need to directly program in Python. So it is actually a Python tool, but we're going to do what's called visual programming, and you'll see, don't worry, it's not that bad. It's actually very, very easy to use. You are, in fact, using Python when you use it, so you can still put Python on your resume, because really you can actually, you can run the Python code in parallel if you wish. but we're going to use this program called Orange, which has been around for 20 plus years. Orange is actually from another country, and it is very widely used in the research and biology and medical fields. It was also, I was going to use CAM's business analytics course. It is actually now appearing in textbooks for data mining in the US, and it is a really good tool, and it will teach you the algorithms, and it's really easy to use. So we are going to use Orange, and there'll be lab videos that show you how to use that. So don't worry. Okay. Ethical issues and limitations. Okay, so those are your tools. There's a lot of other tools as well, but this is really just to illustrate sort of the different types of tools. The general tools, the statistics-specific tools, the data visualization BI tools, the programming languages. And then for this class, we're going to use Orange, which can barely be considered part of Python, but it's an add-on. Well, I mean, it's a separate program, but it is Python-based. There is Python going on behind it. I can't do direct programming in Python because the learning curve and programming ability to do that would just be too high. I want the data mining course to be accessible to people, and there's no real reason to do this course in terms of having people actually code. So I'm not gonna actually code. If you want to actually do the Python coding, because I know some of you have had Python and you can actually do a little bit of this course. I'm not going to grade you on that per se, but we are in fact using Python. We're just using a visual programming Python-based data mining tool and not coding directly. So, and you don't need to know any programming at all to succeed in this course. Yeah. So ethical limitations of data mining. And limitations, data mining is not stats, which is actually a huge... stats, you talk about random sampling from populations. Data mining is rarely randomly sampled, which it can lead to a lot of issues with bias and things like that. And that's something that I covered again in the end of 101. And ultimately, we'll probably have an entire course on ethics and data mining, but not this year because there's too much going on. But one of the limitations of data mining is that it basically is exploratory. It's not experimentally designed and planned it's not a treatment and control type thing like in stats. It's not that mathematically rigorous, which is good and bad. Data mining is not a math subject. It's about finding patterns in data, and from the beginning of this lecture, a lot of data isn't even numeric, so there is no sort of math and statistics directly involved in a lot of it. And I will teach you the math and stats that we do need to know, I cover. So if you haven't had intro stats or a lot of math, don't worry, because we're going to go over it, the stuff that you do need to know. Data mining is exploratory, and then when you finish the data mining, then you might want to go and do further studies and things like that. Data mining is primarily exploratory, which is something very important. We're looking for patterns in a data set. We're not doing controlled science. We're not doing, it's fairly high level, but it's not really like scientifically sophisticated. It's exploratory and it's pattern hunting. Okay. Obviously, limitation of data is it depends on the data used. Often the data is not random, which means that it's not a random sample from a population, so it's biased. Data from the web is inherently biased because it's from the web. Not everybody's on the web. Richer people, people of certain ages tend to be on the web, and education levels, right? And there's also the issue of, where did the data come from? Because I don't know that much about data laws. I got to learn more. And there aren't even that many data laws in this country. Like, laws have not caught up with applications. So, if you scrape data off the internet, which with text data you can do, you can go on Facebook and just scrape Facebook postings. Is that even legal? I don't know. Beats me. Ethical issues, determining if you develop an algorithm for who gets a mortgage and your data was biased, are you being discriminatory? Possibly. There's a lot of things going on here, people. I had one student at the beginning. She was one of the first students in the program that did her associates, and her interest was in data and law, and I think that's really a great idea. Obviously a lot of people in here wouldn't be interested in law, including me, but let me tell you, if you have data skills and go into law, that's probably a great combination, because there's a lot of issues. Legal and ethical issues are not well defined. So as a summary, data mining should be primarily thought of as an exploratory process. Your goal is to find helpful patterns in data, which is something very important in business, finding customer trends, and there's all kinds of things you can do with it. So this course is about the data mining techniques and the different ways to hunt for patterns in data. And that is what we are going to do the next several weeks in here. Okay? And this is the end of week 1.